My name is Ahmad Khalil Khan, and I will be presenting on the behemoth ocean of ancient Mars. If you look through your telescope today, you will see a reddish planet that is devoid of any ocean whatsoever. This is planet Mars. The reddish coloration of Mars is due to the iron oxide dust that is prevalent on its surface. Mars is a smaller planet than Earth. As a result, it has a weaker gravity of only 40% of Earth's gravity. Moreover, it also has only 1/150 of Earth's atmosphere, which is very, very thin. A possible reason for the thin atmosphere of Mars is due to erosion via solar winds. This caused Mars to lose much of its pressure and heat that is required to retain and keep the water in liquid form. As a result, the water shrank and eventually froze over in the north and south polar caps. The polar caps are now a prominent feature when you look upon Mars through your telescope, as you can see from the image. Upon the discovery of evidence that points towards the possibility of discovering water on Mars, scientists embarked on a project called Follow the Water in 2005. The purpose of the project was to discover how deep the subsurface ocean on Mars can possibly be, and this led to the discovery of the ancient ocean on Mars. In order to discover this ancient ocean on Mars, scientists from the NASA Goddard Space Flight Center used 3 of the world's major infrared telescopes to create an infrared map of Mars. From this map, they used it to analyze the atmospheric compounds that are found on Mars, especially for water. What they discovered was that the ratio of heavy water, which is water made up of deuterium, oxygen and hydrogen, is much higher as compared to normal water. Hence, they theorized that much of the normal water was lost to space, leaving the heavy water to be retained in the polar ice caps. Now, you may think, how is such a discovery significant? This discovery proves to be a very strong impetus for scientists and engineers alike to pursue the dream of colonizing Mars for human habitation. Human habitation requires water, and the cost of transferring water to Mars has always been the biggest barrier for this dream. Now, with this discovery, it opens up the possibility of discovering water beneath the surface of Mars, and would greatly reduce the cost required to colonize Mars. Hence, scientists and engineers can then focus their minds and effort into creating technologies that will greatly assist mankind, such as agriculture, harvesting, and creating oxygen that will make it sufficient for humans to stay on Mars. Moreover, Mars has been said to remain wet for more than 1.5 billion years ago, and as a biologist personally, this has a great impact on me. Why? Because 1.5 billion years is enough for life to develop on Mars. If such a discovery is true and you will find oceans beneath the surface of Mars, this opens up the possibilities of finding life and microorganisms that may have developed on Mars. It would be interesting as a biologist to understand the physiology and the biology of animals that have lived or are still alive on Mars, and this would open up a very big and new branch of biology, which is extraterrestrial biology, and this will enable science to have a better understanding of how life can come about on a planet. And with that, I would like to thank you for your kind attention and listening to my presentation.